Good evening everyone, welcome JEE enthusiasts. We have been riding bikes for quite some time now in circular motion. We have gone around loops, we have gone in straight lines, we have gone in the curves. But how about some stunts, something like this? And understanding the science, understanding the physics behind these stunts. Look at these stuntmen, look at these riders going up in the air, performing stunts. What a cool scene to see. What an amazing stunt this is. How about that? Look at this bike guy going up the ramp. What exactly is happening? What is moving in that curve path? So let's talk about all this with me, Shreyas, your master teacher for physics at Vedantu, going live. Welcome aboard everyone. And I was just reading all your chats and I guess it's somebody's birthday. Well, happy birthday, Krito. Welcome, and guys, keep this tradition. So if it is somebody's birthday, you should let everybody know about it. If there is some special thing which you have got which is special to you, you should definitely put it up in the chat box. I'll be reading it. Maybe sometimes I might miss it, but I'm pretty sure others are also going to see that, and you should let others know. That's what we do at JEE Enthuse. We are all a family, so we should celebrate each and every event, be it mine, be it yours. So welcome aboard everyone. Hi Aisha, Jumna, Arthi, Pawan, Dilip, Science Priya, Srivats, Mukut. Welcome aboard. Hi Janvi, hello Sanvi, welcome. Hello Srivatsa, hello Uncharted. Yes, it's kind of, see, so today onwards, let me tell you guys, we are going to make sure that your syllabus gets completed before your first attempt. Yes, before your boards and January attempt. Don't worry, all the major topics will be covered, be it 11th standard, be it 12th standard. So all the 12th standard guys, all the 12th standard and the dropper guys out there, please listen in carefully. Do not worry, we have heard you, we have seen all the comments, and we are going to come up with the 12th standard portion starting tomorrow in physics. I'm going to start with electrostatics. So one day I'm going to choose some 2-3 topics in electrostatics. We are going to do some problems, we are going to do some theory, we're going to see the formulas, and that will be a very good revision for all the 12th standard guys out there. So I hope all the 12th standard guys are listening. Thursday, Friday, I'm going to start with electrostatics. Then next week again we'll go to Gauss law, then current electricity, magnetism, electromagnetic induction, modern physics. All the topics will be done. Don't worry, we still have 2.5 months of time. Do not worry about it. And 11th standard, do not worry, we also are listening to you. So 11th standard portion will also continue simultaneously. Alright, so keep learning, keep coming, keep posting, keep liking, keep sharing. Only then we are going to do more and more stuff for you. Unless you like, unless you subscribe, and unless you share all these things as stories, as social media posts with your friends, guys, this family won't become bigger and you won't have fun unless this family becomes bigger. So keep posting, keep liking, and keep sharing. That's what I would say. Welcome aboard. And yes, Kirito, I will talk about resolution of vectors at the end of it, right? So let me just get to the center of mass theory today. Now, yes, Uncharted, MI1, and like I predicted yesterday, I don't know how many of you saw my lecture yesterday. I know most of you were there. I just predicted MI will win. I don't know, and it just so happened that they won. What a match it was. And if you have not seen my lecture on cricket yesterday, you should definitely go and check it out. It's created quite a sensation out there. All right. So yes, Prija, yes, Prija, because center of mass is a small chapter, but if it is a big chapter like rotation, I won't finish it in one day. It's not possible. So I'll be taking parts of those chapters and then I'll be completing it. Alright, so understand small chapters like example fluid statics. It can be easily done in one lecture, or viscosity and stuff like that. It can be easily done. So those kind of things will be done in one lecture, but big chapters like electromagnetic induction, magnetism will take 1, 2, 3 depending on how big the chapter is. Alright, very good. Yes, VSG, my prediction. Let's begin the session. And yeah, keep this chat box alive. Optics also, obviously, Dinesh, everything will be covered. Do you think I will leave anything? Obviously, I will cover optics, I will also cover semiconductors, I will also cover communication systems. Everything I'm going to cover, you wait for it. Those chapters are easy chapters, so I'll do it in the end. And by the way, this Saturday I'm conducting a very special session, so stay tuned to see what I'm going to do on Saturday. Very hatke session, very different session on Saturday. Thank you, Rahit. Love from West Bengal. Nice, nice, nice. Okay, so in the last session we have seen cars on Bank Road, but we didn't worry about why it didn't topple. So let's talk about what exactly center of mass has got to do with it, and what determines if something topples or if something will fall, like that stunt riders out there. Okay, and look at this dude. Look at this dude going on the bike. Oh my god, I think he just fell down and the bike just went away. Oh, bad. So what exactly is happening? How is he able to balance? What is he miscalculating, because of which he is falling? Alright, so why was he unstable? What makes something stable? That's what we are going to discuss. Look at this dude. He's quite stable on his bike. I think he's doing something in the right way, because of which he's stable and he's definitely not falling down, of course. So for that we need to understand this concept called as center of mass. And you would have played around with many toys out there in the market, where you get a doll, where you push it, it comes back. You push it here, it comes back. So that doll works on the principle of center of mass. Alright, now what is center of mass? So center of mass is that point where you can assume the body's mass to be concentrated. So for example, this pen, there are many masses on this. Where can I assume the mass to be concentrated is called as the center of mass. Alright, now think about it, guys. Very simple thing, I'll tell you. Okay, so imagine this remote. Okay, this remote out here, there are many points on it. I know the center of mass will be somewhere over here. Now if the entire thing's mass is concentrated here, so understand, the moment I hold it like this is the suspension, this is where the mass is concentrated. This thing can be thought of like a pendulum, where there is a point mass here and there is a string connecting the point mass and the suspension point. So what will happen if I move the pendulum like this? It will come back, correct? It will be in stable equilibrium, because the entire pen's mass is concentrated here and the center of mass is below the point where I am hanging it or suspending it or where I am pivoting it. So if I have a pendulum where mass is here, point of suspension is here, obviously it will be in stable equilibrium. That's something what we have already seen. Now what if I make it opposite? The point of suspension is here, the center of mass of the remote is here. This is like an inverted pendulum, and we know what happens to an inverted pendulum. If the mass of the bob or the pendulum is on the top and the hinge is below, obviously it's quite unstable. It will either topple this way or that way, even if you give it a small push out there. So guys, understand, the center of mass concept helps us build understanding of complicated situations by assuming the object like a point mass. So it makes things little bit simple. Also, another kind of example that I can give you, imagine this remote is going like this. Okay, it is going in some weird fashion like this. Now, if this remote is going in some weird fashion like this, you can clearly see each particle on the remote is traveling differently. Alright, each point is moving in different paths, with different velocities, with different accelerations. But if you sit on the center of mass, you will see the center of mass going like a trajectory. When you throw the pen, you will see that the center of mass will go in a nice parabolic path. And if you sit on the center of mass, what you will see is only the rotation of the pen. Yes, you will only see the rotation of the pen or that remote, alright? And the center of mass itself will be moving in a trajectory, that parabolic path, just like you have learnt in a projectile motion. So you can see what center of mass has done. The study of center of mass has helped me or enabled me understand the motion, which is quite complicated right now. Like this remote is moving in a very complicated manner. So what I have done, if I look at the center of mass, it looks like a projectile like this. And if I sit on the center of mass, I just see rotational or circular motion. So it's enabling me to make the calculations, make it a little bit simpler. I hope this is clear. Yes, Rahit, I have come. Yes, and this session is also useful for NEET 2. Okay, great. Welcome, lady. Welcome. Okay, so that's what center of mass has done. It has enabled me simplify a complicated motion, split into just translation, and sitting on the center of mass, I just see a rotation. So that's how center of mass is useful. Now, Let's understand this concept more in detail, but let me give you a very important news. Today is the last day of the offer. Yes, today is the last day. In case you do not know what I'm talking about, the Vedantu Pro subscription, which will enable you to get and attend all the live classes, the micro courses, the crash courses, the numerical courses, the book discussion courses, the nationwide test series, the assignments, the Tattva module, and all the problems that Vedantu gives you. Also the doubt handling. There is a doubt feature in Vedantu app where you can post your doubts and our experts answer back. So a lot of you have a lot of queries and you don't know where to go, whom to ask. A lot of teachers don't answer in your coaching institute, right? And in YouTube it is very difficult generally. So if you want to get your doubts answered, yes, Vedantu Pro subscription is for all of you, and you also get the option of English and Hindi for almost variety of courses out there, and you will obviously get really experienced teachers who have produced amazing ranks in the respective fields. So the Vedantu Pro subscription, guys, is like your Netflix or your Amazon Prime subscription. You don't have to pay anything extra for crash, for numerical course, for for test series. No, it's just one time payment, something like this. Like if you take the subscription for 1 month, it is 9,000. If you take it for 6 months, it is 51,000. But the offer right now is 50% off. So you can get a good discount right now. Please understand that the cap limit, of course, is 10,000 rupees. But that's okay. This is for the droppers. For the 12th standard students, for 6 months, it's 39,000 rupees. And for the 11th standard students, it is 42,000 rupees. But right now there is 50% offer going on, and it ends tonight. Yes, it ends tonight, guys. So do not waste any more time. Please register today, or else you will be missing this very nice opportunity to study under the amazing master teachers at Vedantu. So what is the coupon code you have to use? You have to use SHHPRO. That's your coupon code. The link where you can join, and all the FAQs, all your questions are there in the description. The link has been shared in the description. Just open up that link later on, not now, and then read all the questions, all the testimonials, all your doubts are answered on that page. So before enrolling, you can read all these questions, and with peace of mind, you can definitely enroll into this subscription using this coupon code. Get this off. It ends tonight, let me remind you again, and the cap limit is 10,000. So don't wait. So now, yes, Marvin, yes, of course. Yes, Rahit, I do know Pritesh sir. Now, let's talk about two masses. What's the formula? So, if I have two masses, M1 and M2, let's say M1 is at X1 coordinate and M2 is at X2 coordinate, then their combined mass, okay, their combined mass, which will be M1 plus M2, will have some new coordinate, which I'll call it XCM, and I hope you know the formula. XCM is nothing but M1 X1 plus M2 X2 divided by M1 plus M2. So this is the formula for finding the center of mass. Coordinate, the mass of the center of mass is just the addition of the masses. Understand? The location is given by this formula, M1 X1 plus M2 X2 upon M1 plus M2. That's fairly simple. That's something which you should know. Now you might be like, what if there are more than two particles? What if there are n particles? Well, then also it's simple, guys. It's nothing but if each particle, let's say I call this particle number M1, this is M2, similarly this is Mn. N stands for the nth particle. Then the x coordinate of the center of mass is given by M1 X1. Just that you will have many terms. The last term, guys, what would it be? It will be Mn. Yes, it will be Mn Xn divided by M1 plus M2 till nothing but Mn. But that will give you the x coordinate. Similarly, don't you think there will be y coordinate of the center of mass as well? So the entire masses can be thought of to be concentrated somewhere over here. Center of mass will have x coordinate, y coordinate, and even z coordinate. So same way I can say the y coordinate is m1 y1 plus dot 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 upon m1 plus m2 dot dot dot. And similarly the z coordinate can be given by m1 z1 plus dot 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 divided by m1 plus dot dot dot. I hope this is fine. I hope this has reminded you, it has refreshed your memory about center of mass. Okay, clear? Clear, guys? Is it clear, everyone? Shall we go ahead? Very good. Now, having said this, what if, okay, just one sec. What if it is a continuous body? What if there are no distinction? There's no distinction between the particles. It's a continuous body. In that situation, you can take some dm mass. One sec. You can say take some dm mass. Dm is a very small mass, and it will have some coordinate. Let's say x, and the center of mass of this entire body might be here. Maybe this is the center of mass, and that would be the x coordinate of the center of mass. In that situation, the summation gets replaced by integration. Remember, when you have many terms but each term is very small, then the summation gets converted into integration. So integration is nothing but adding up of very small terms but many terms, infinitely many terms. So it will become integral. Instead of m1 x1, it will be dm into x. That's the only change. And instead of m1 plus m2 plus m3, it will be total mass. So that's the only change in the formula. This integration can be performed. You can refer your NCERT books or HC Verma. For different bodies, this integration has been performed. We'll be taking some problems on this integration in some advanced class, not in the mains class. Alright? Okay. So, what will be YCM? Similarly, you will get it as integral dm into y upon the total mass, and ZCM obviously will be integral dm into z upon the total mass. That's what you will get. That's the formula for a continuous body, not discrete particles. That's the change. Unfortunately, this is a English channel. A lot of people who will not understand Hindi. So that's why I might crack some dialogues in Hindi, but I cannot use too much Hindi, guys. Understand, this is a English exclusive channel. Alright. So understand that. Okay. So let's go ahead. Let's talk about the different geometries and where the center of mass is. This is very easy. So guys, for symmetrical bodies, uniform bodies uniform means that the masses are distributed evenly, the density is constant. Then for a solid sphere, obviously it is at the center. Okay? It is at the center. Same thing for hollow. Hollow means imagine you just take an egg and you don't have the inside liquid part, or you just have an orange but only the outer covering is there, but inside orange, actual orange is not there. So that's a hollow sphere. Then solid cuboid, hollow cuboid, all things that's always at the center. Solid cylinder, hollow cylinder, it's always at the geometrical center of those bodies. So that's where the center of mass lies for uniform bodies, symmetrical bodies. But that's not the difficult part. This is quite easy. The challenging part will be when it is something else, then where is the center of mass? So I'm going to give you some formulas which is going to help you. These are the only formulas which you should remember for NEET, JEE, JEE Mains, JEE Advanced. That's it. Nothing more, nothing less. Okay? So remember these formulas, that will help you. So for a solid hemisphere solid means taking a sphere, cutting it, that's a hemisphere. The center of mass will be somewhere here, and we are only talking about this distance. That distance for a solid hemisphere comes out to be 3r by 8. That's the formula. It comes after integration. Hollow hemisphere, this distance comes out. Remember, it's not from the top, it's from the bottom, the flat base. Comes out to be r by 2. So that's the formula for hollow. It's a shell. Hollow hemisphere and shell are the same things. Do not get confused. Hemispherical shell, both are the same things. Yes, KVPY also. You don't need anything else more than that. This is same as a bowl. You take a bowl, a katora, and you make it like this. That's nothing but your bowl in which you can cook your vegetables. Okay, solid cone. Solid cone is like an ice cream. You would have had those ice creams, yummy ice creams full of ice cream. That is solid cone. For solid cone, the center of mass is somewhere here, and we are talking about this distance is nothing but h by 4. Okay, so it is h by 4. But for a hollow cone, that means you eat the ice cream but you leave the wafer. So inside part of the ice cream, that's gone and only the cone is remaining, the wafer is remaining. That's basically h by 3. Is that fine, guys? Yes, ulta birthday cap. Yes, this is like a birthday cap which you wear, and you can put some smileys out there for that emoticon which is there where somebody is blowing some trumpet kind of a thing and he's wearing a party hat. All right? Yes, correct, clear? Okay, now I'm going to change your formulas, guys. Understand, I'm going to give you one very special formula so that you don't have to remember some more formulas. I'm going to give you a very special formula, and that's it. That will help you solve any other problem apart from spheres and cones. Now, what is that formula? Solid sector and arc of a circle. Now, everybody would have had pizzas, right? I'm pretty sure. So when you have a pizza, right, you get those slices. Each slice, I can call it like a sector. It's a solid sector. That means it's like a thin sheet, but there is some angle subtended. Okay, so that's the slice of the pizza which we are talking about. Alpha is the angle of that slice, R is the radius of the slice, L is the length of that arc. So this is where the toppings will be, and this is where the crust will be, that hard part, that crispy part, and stuff like that. I hope your mouths are now watering. Now the center of mass will be exactly over here, okay, and this distance is what I'm talking about. This distance, okay, if I call it d, is equal to, remember this formula, is 2 by 3 r is that radius, into sine alpha by 2 by alpha by 2. That's what you should remember. 2r by 3 sine alpha by 2 by alpha by 2. If you remember it, that's it, your job is done. You know the distance. It's on the angle bisector. Very important formula. I'll tell you where you can use it in a bit. Okay. Now, if this is clear, next point is arc of a circle. You ate the pizza, but sometimes people don't like the crispy part. So the crispy part is only left. Inside part is eaten up. So the center of mass will be somewhere here, guys. And this is the distance that I'm talking about. Okay, this distance where the center of mass will be. Okay, that distance is very similar. It is r sine, by this sine theta by 2 by theta by 2. Okay, there is no factor over here. That's it. So remember, both these formulas are identical. In case of an arc, it's slightly more inside over there, so there is no factor. But in case of a sector, it comes close to the center, so that factor of 2 by 3 brings it closer. I hope this is fine. Rahit, please don't spam over here. Don't spam. Okay. Okay. So this is something which you should remember. Now let's use this. Shall we use this? Okay, Aarti is feeling hungry. Shall we use this, guys? Yeah? You want to learn how to use this? Shall we start? Okay. Remember, I hope you're writing down all these formulas in your notebook, because I'm going to go to the next slide. This formula will disappear. So please write down all these things. Okay, great. Chalo, let's go ahead and let me tell you how you can use it. Imagine you have been given a problem where there is a semicircular disc. Okay, this is a complete disc, understand that? Again, this is a complete disc. So something like this. Now the question is, where is the center of mass? Now the radius is given, whatever is needed is given. So first of all, I know the center of mass will be somewhere here, and I will just figure out what is this distance. How do I find out this distance where the center of mass is located? Very easy. I need to use the sector formula. What was the sector formula? D was, remember, for sector it is 2 by 3 r sine something by 2 by something by 2. What was that something? The angle of the arc or the sector. So what is the angle of that arc? Think about it. What is this angle? Think about what is this angle? That's the arc angle which is subtended. So that is 180, but do not put the angles in degrees. Always remember, you have to put in maths and physics angles in radians. So it is actually pi radians. Same thing over here. So shift that 2 on the top. It will become 4 by 3. Okay, that 2 went over there. And r, sine of 90 is just 1, and that's the answer. I hope it is clear. So easy. You don't have to memorize the formulas for these things separately. I'll give you one more example. Imagine you have been just given quarter of a circle. Okay, just quarter of a circle, and it's just an arc. And now the question is, where is the center of mass? Again, let's use the same logic. So the center of mass will be somewhere here, and this distance d is what I need to find. So think about it. This d will be just r sine of some angle by 2 divided by some angle by 2. Now what is that angle? Believe me, that angle which I am talking about is 90 degrees. Check this out. This is 90 degrees. So 90 degrees means pi by 2 radians. So put pi by 2 over here and pi by 2 over here, and you will get the answer. This 2 and this 2 will go up, and it will become 4r by pi, of course, 4r by pi, and sine of pi by 4, that means sine of 45 degrees. What is sine of 45 degrees, guys? 1 by root 2. So hence just put 1 by root 2, and that is the final answer. Isn't it making your life so simple? Thank you, Ani. What about pi? So that pi is, oh, I think I forgot the pi in the previous part. Oh, sorry. Oh, I think I was hungry, guys. That's why I think I forgot that pi. Okay. Yes, science Priya. Yes. I think I was hungry. Maybe that's why. Alright. I hope this is clear, guys. You can take anywhere. Yes, Krito, I put that pi. Yeah. So you can take the origin to be anywhere, or it will be given to you where is the origin in the problem. So you don't have to worry, sir, which side should I take, positive, negative, where is the origin? Don't worry, it will be given to you in the problem. Okay? Very good. Yes, I ate the pie. Okay, let's go ahead. Let's go to some more problems. Now, look at this problem. Masses are 1.5 kg, 1 kg, 2 kg and 1 kg are situated at 2, 1, 1, 2, 2, -2 and -2, 1. So the question is, find the position of their center of mass. Alright. So, let's see what we can do. So, I believe you just have to show which masses are where. So 1 kg is at 2, -1. So this is 1 kg. Then 1.5 kg is at 1, 2. So this is 1.5 kg. And 2 kg is at 2, -2. Okay, I think this point should not have been here. It should have been here. Okay, so 2, -2 means that will be 2 kg, and last mass 1 kg is situated at -2, 1. So this is where that 1 kg is. Okay, this mass is not there, guys, just ignore that. Okay, this mass is not there. Alright, so how will you find out where the center of mass of all these particles is? Just use the formula xcm is equal to m1. So you can start with this mass. m1 is 1 into x1 is 2 plus m2 is 1.5 into x1 is nothing but just 1 plus m3 is 1 into x3 is -2 plus this one m4 is, let's say, 2 and x4 is again 2. This entire thing divided by the total mass. Total mass is 1 plus 1 plus 1.5 plus 2. So guys, what are you going to get? Calculate. Just calculate. Yes, HCV is very good. SL Aurora is not that great, guys. I don't like SL Aurora so much. It's not that comprehensive. DC Pandey is also good, yes. Okay, what is the answer, guys? Come on, 2 plus 1.5, come on, that minus 2 and 2 will go out, 2 to the 4, and 4 plus 1.5, 5.5, and what are you going to get over here? Just check it out. Yes, this is also 5.5, so this is 1 meter. So the same way you can find the y coordinate. So that's how you can do it. Now these are basic level questions which can come for JEE mains, yeah, basic level questions. But there are times when JEE mains also will ask good level questions, or in JEE advanced. So then I will give you some 4 tricks which will help you calculate. Already actually I have given you one more extra trick where I give you the general formula for the arc and the sector. Now I'm going to give you 4 tricks which will help you solve problems, guys. So let's get going, and let's get going. So you just know how to solve these kind of problems. These are pretty easy. BM Sharma is also good. It's good, it's good. Trick number 1. What is the trick number 1? It says inverse ratio trick. Many of you might know it subconsciously, or you would have learned it, but nevertheless there are many people who do not know it. So what does this trick say? See guys, if the masses are m and m, the center of mass will be exactly at the midpoint. So these two distances will be equal. Okay, but imagine the masses are not equal. This is m and this is 2m. So now if the total distance is something, understand the center of mass will be more inclined towards the heavier mass. So the center of mass will be here, and guess what? If this and this distances are called as r1 and r2, understand r1 by r2 will be inversely related to masses. r1 by r2 will be 2m by m. That is, it is in the ratio of 2:1. So center of mass divides the line joining the two masses in the inverse ratio of the masses. That's the trick. Alright? Great, thank you Devash. Now understand that this can be used to find out the center of mass directly without actually applying the formula. How? Imagine once you have understood this trick, imagine I tell you this is 1 kg and let's say this is 2 kg, and let's say the distance between them is 6 meters. Now I know the center of mass must lie somewhere here, and this distance is to this distance will be in the ratio of 2:1. That's the ratio, inverse ratio. So can you divide 6 in the ratio of 2:1? Can you divide 6 in the ratio of 2:1? Guys, come on, it's very simple. 4 and 3, right? I hope you can see that. So this will be, sorry, 4 and 2, my bad. 4 meters, and this will be 2 meters. So that's the ratio of 2:1. So simple. So simple. Not 4 and 3, 4 and 2. Okay. I hope this is clear how we can do this. And similarly, you can do this for other problems also. Let's say this is 10 meters. And let's say, I don't know, maybe this is 2 kg. And let's say this is 3 kg or something like that. So then, again, the center of mass will be somewhere here. This distance is to this distance will be in the ratio of, flip it, 3:2. So divide 10 in the ratio of 3:2. How can you divide it? Come on guys, divide 10 in the ratio of 3:2. I hope you got it by now. This is 6 meters and this is 4 meters. That's how straightforward it is. No wish, I'm not sure of that book. Clear? So that's your first trick that you have learned only because you have come to JEE Enthuse. Now, let me tell you trick number 2. Very important trick. Independence of motion along perpendicular axis. Very important trick. Now, understand, by the way, that all those tricks come from, whatever tricks I gave you, inverse ratio trick, it comes from the formula only of center of mass. If you take the origin to be somewhere on the center of mass, you will see m1 x1 minus m2 x2 will be 0, and m1 by m2 will be x2 by x1. So that's easily provable if you use the formula for center of mass. That's not difficult. I hope, Saurabh, now it's clear, you can get it. So just replay this part, but now concentrate on the second trick. Now, the second trick is also again very simple. If I have m1 mass, one sec. Okay, if I have this as m1 mass and if I have this as m2 mass, if m1 moves like this, understand their center of mass will also move like this. That is when there is a line joining the two masses. Okay, so what is the line joining the two masses? It is like this. And one of the masses moves perpendicular to the line joining the two masses, their center of mass will not change the coordinate. Yes, the center of mass will not change the coordinate. It will only, x coordinate, that is, it will only move like that. Now, why is that so? It's very simple to see that if center of mass is here, okay, just imagine this. This is M1, this is M2. This is a line joining them. Let's say the center of mass is somewhere here. After some time, when this mass goes here, understand, if I again join these 2 points, that's the new position of M1. The center of mass again should divide this line in the same ratio as it did over here. The ratio should be same, so hence it should move parallelly. Remember, that's the property of parallel lines. I hope it is evident now. That's the property of parallel lines. Two parallel lines divide any line which is intersecting them in the same ratio. That's how it is, right? So you can use this trick in many places, like, you know, there is some mass here and there is some mass here. Okay, mass 1 and mass 2, and you have to find the center of mass. Where is it? So just move this mass like this. Doesn't matter. Understand, the x coordinate of the center of mass will not shift. It will just be here. So you don't have to worry, right? When you bring this mass here, the center of mass will just come here. The x coordinate won't change. Similarly, you can go the other way around. You can also obviously take this mass like this. In that case, the center of mass will just come like that. It will not move anywhere else. I hope this is fine. Understood? Clear? Clear, everyone? Okay. So the assumption only is that the motion should be perpendicular to the line joining the two masses. That's all. Very good. So let's go to the next trick. Next trick is addition trick. Very easy trick. Now, what is this addition trick, guys? So the addition trick says that if you have two bodies whose center of mass is known to you, you can also find the center of mass of the combined body. And it often happens. Like I can give you an example. So say, again, I can think of some ice cream. So imagine you bought a nice cornetto ice cream and it looks like this. Nicely filled with a lot of ice cream out here. And now I want to find the center of mass of this ice cream, guys. So you know what I'm going to do? I'm going to break the ice cream, not actually, but mentally or just visualization, into a hemisphere and a cone. And I know the center of mass of a hemisphere. I also know the center of mass of a cone. So adding them, I can get the center of mass of the complete body. So that's the logic of that. Yes, today's session is so tasty. Okay, so now coming back over here, if there is a body which can be composed of two smaller bodies, you can always add using the center of mass formula. And what you need to do is to find the center of mass of this combined body. Just you should know the center of mass of body 1 and center of mass of body 2, and then just use that formula, standard formula, m1 x1 plus m2 x2 divided by m1 plus m2. Just use this, you will get the x coordinate wherever the center of mass is of m1 plus m2, you will get the x coordinate of the center of mass. Let's try out a problem, only then you will understand it. That's a better way of doing this. Okay, so gear up for a problem, guys. Let's do a problem on trick number 3. Let's do this. Read this question. Read this question. No problem, Fida. Join in. It's okay. Join in. Okay. So, read this question. Two steel spheres of radius r and 4r are made to touch each other. What is the distance of the center of mass from the point of contact? They are made of steel. Does that mean that if the radius are different, their masses will also be different? Yes or no? Come on, think. Will their masses be different? Yes or no? What do you guys say? Will the masses be different? Because they are both made of steel, but radius are different. Correct? Yes or no? Yes. Okay. So now let's figure it out. How do we get this? Now let's say I call the sphere of radius r as mass m1, the sphere of radius 4r as mass m2. And since both of them are made of steel, their density is, let's say, rho, some density rho. This is their common point. Okay, the big sphere has the mass concentrated over here, that is M2, and the smaller sphere has the mass over here, which I'm going to call it as M1. This is just, let's say, the origin, and let's say this is our x-axis and this is our y-axis. That's all. So that's the convention that I assume. Now remember, to use M1 x1 plus M2 x2 upon M1 plus M2 formula, first I need to know what is M1 and M2, right? So let's just figure out what is masses. What are those masses? So how do we find mass? Guys, remember, mass in general is nothing but density multiplied by volume. So let's use this fact. Mass is density into volume. So M1, think about it, M1 will be density into volume of that solid sphere. How much will it be? 4 by 3 pi r cube. Great. What is M2? M2 will be density into that sphere's volume, which will be 4 by 3 pi. What is the radius? 4r. So 4r whole cube. Okay, great. So this will become a rho 4 by 3 pi r cube multiplied by 4 cube is nothing but 64. So I'll keep it as it is over here. Now the next step will be, where would the combined center of mass be present? Where is the combined center of mass present? I don't know. I'm just assuming the center of mass is here. I am interested in what is the coordinate of the center of mass. So think about it. XCM will be M1 x1 plus M2 x2 divided by M1 plus M2. Let's try this out. I hope everything is fine till this point. Now, what is M1? M1 is this quantity. So it is rho and this thing, 4 by 3 pi r cube into x1. What is the x coordinate of M1? Guys, I hope you can see it. The x coordinate of M1 is nothing but just r. I hope you can see that. And what is the x coordinate of mass 2? I hope you can see that this r is nothing but x1 and x2 is nothing but minus 4r. Be careful, it's negative because it is on the other side. So that's the main catch. So x1 is nothing but r and plus, what is M2? M2 is this big term. So rho 4 pi by 3 r cube into 64 into x2. x2 is nothing but minus 4r. This entire thing divided by M1 plus M2. That means I need to add both of them. So rho 4 by 3 pi r cube plus this term over here, which is rho 4 pi by 3 r cube into 64. Just check this out. See if I missed anything, any term out here. Just check this out. No problem, poetry, just join in. It's okay. I hope I have done it correctly. Okay, so now you can see many terms will get cancelled. 4 pi by 3 rho r cube will get cancelled everywhere. Even this, no, that r will not get cancelled. So what will I be left with? I'll be left with r, okay, and this will be minus, and I'll have 64 into 4. I hope you can see that, guys. That is my 256. So 256 r, that's what I'm going to get, I believe, over there. And upon here, I'll just have 1. Remember, everything else has got cancelled from everywhere, and I'll just have plus 64. So what will be the answer then? This will become minus 255 divided by 65 times of r. You can simplify it, but you get the point. I hope this is fine, guys. I hope this is fine. Everyone understood how to solve these problems? So these are good level problems. R is the radius, right? It is given. Very good, very good. Okay, so let's go to the next type of problem. Let's go to fourth trick. Okay, so let's go to the fourth trick. So this is how you should use when densities are constant. Always use the fact mass is density into volume. First thing, you will calculate mass, and then you will substitute the mass in the center of mass formula. Rest is just calculation and using the proper signs. That's it. Now, next trick, subtraction. You would have guessed it. Looks like a SIM card though. So if there is a hole or some cavity, so guys, what you need to do? The formula is, first assume that the hole is not there or the cavity is not there, like this body, and imagine the hole to be a separate body. Now the logic is, if let's say the center of mass of this body is somewhere here, the center of mass of this body is, let's say, somewhere here, and we need to find out where the remaining part, sorry, this is not m1 plus m2, this is m1 minus m2, because I have taken out something. So the remaining part's center of mass can be found out by xcm is, can you guess what will happen? It will be minus m2 x2 divided by m1 minus m2. So that's the only change. Instead of plus, just put minus, your problem is solved. As simple as that. I hope this is clear, guys. Yes, just take negative mass. That's all. That's all. Okay. So I would be very interested to see how many of you get the right answer to this question. You have to post the correct answer in the comment box below. The method is the same. Instead of two spheres being separate, I have taken out a cavity from a bigger sphere. So from a sphere of radius 2m, a sphere of radius 1 meter is removed from the edge, like shown over here. What is the shift in the center of mass? Alright, so think about it. Post the answers not now. You cannot post it in the chat box. You have to post it in the comment box. And the comment box will be opened only after the chat closes. That's after the session ends, not now. So keep this problem in mind. You have to post the answers in the comment box. I'll be posting the solution to this problem on our Telegram group. So check out the Telegram group for getting the proper solution so that you know you guys are correct or wrong. Alright, so let's do that. Okay, so I'll just give you the hint that you can take the big thing and take the small thing and subtract them, and that's it, you will get the answer. Alright, so try this out, it's very easy. Now let's do something very exciting. How about finding the center of mass of a triangular sheet which is neither isosceles or equilateral or right angle. It's some scalene triangle. Where is the center of mass? Well, the logic behind this is a sheet, right? So why not divide this sheet into small rods like this. I'll divide the sheet into small rods like this. Now, I do not know where the center of mass will be because it could be either orthocenter, or it could be in-center, or it could be circumcenter, or it could be centroid, or it could be none of them. I do not know where it is. So I cannot start with the assumption, oh, I know, sir, it will be at the circumcenter. That's not a fair assumption to do. Now, for each rod, where would the center of mass of the rod be? Think about it for each rod. Let's say I take a rod here, the center of mass will be exactly in between. For this rod, again understand the center of mass will be exactly in between. So these are the points where the center of mass will be for each rod, correct? Now these are the center of masses of each rod. So think about it. The center of mass of the entire triangle will lie somewhere on this line. The center of mass of the entire triangle will lie somewhere on this line. I do not know where, but somewhere on this line, that's for sure, correct? Now, what is this line actually speaking? This line, guys, is nothing but the median of that triangle. It's nothing but median. So, if it lies on the median, that means had I divided this triangle into some other way, like this, one sec. Had I divided the triangle maybe like this, then think about it. The center of mass would have lied on this median, right? The center of mass would have lied on this median. So where would the center of mass lie? Think about it. The center of mass will actually lie, pakka for sure, on the intersection of the medians. It has to lie somewhere on the intersection of the medians. So hence, this point is nothing but centroid. So the center of mass of a triangular sheet lies at the centroid of that triangle. Very important. And see, look at the way I have proved it. Very interesting. Excellent. Very good, Jasil, Hardik, Nitish. Nitish, that will be a very special case. Okay. Okay. It's not a hollow cone. Yes. Yes. Yes, Liti, for sure. For sure. No problem, Navami. No problem. Yes, yo poetry. Excellento. Excelente, VSG. बहुत ही बढ़िया. You learnt my lingo. Okay. Let's move ahead. Like I told you guys. See, a lot of you are asking, sir, can we go very slowly? Guys, understand, we have very limited time. We have to complete the entire thing by January, February, because we have started, or you guys have started the preparation probably with us, in the month of October. So if you want to complete the portion by, January or February, so we need to do a lot of things. So guys, I need your full support. I hope you guys are onboarded on this. So guys, remember, we are going to do all the chapters. We are going to prepare you for the examination, be it JEE Mains, boards, whatever it is. And 11th standard students also, do not worry. We are going to complete the 11th standard syllabus also. Do not worry about this. Okay. Now, how about this question? Motion of center of mass. Very good. Very good. Okay, motion of center of mass. Let's have a look at the formulas for motion of center of mass, and there are some amazing problems that I have planned over here. Now, if all the particles are at rest, obviously the center of mass will be at rest. But if each particle starts moving, then obviously center of mass will start moving. So what will be the velocity of center of mass formula? Very easy. Imagine, guys, if each particle has certain velocities v1, v2, vn, etc. like this, and the masses are m1, m2 and mn like that. So their center of mass velocity is given by the same formula, m1 v1 plus m2 v2 plus mn vn divided by the total mass. That's it. That's the formula. And please keep in mind, these are all vectors actually. So if one velocity is here and the other velocity is there, you should account for the sign changes. Yes, you should account for the plus and minus. And you'll be like, sir, what if one is here, one is there, one is here? Well, you know what to do, I cap, j cap. So just put all the values in I cap and j cap. You will get the final answer also in I cap and j cap. So that's the trick for these problems. Okay. Great. Chalo, let's go to the next part. So, if the particles are moving and they are also accelerating, then their center of mass might also accelerate. So, if each particle has some acceleration a1, a2, you would have guessed it by now what should happen. If the particles' accelerations are a1, a2, a3, etc., and we are talking about their center of mass, okay, their center of mass, what acceleration it might have. So the acceleration of the center of mass, again same formula, m1 a1 plus dot 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 mn an divided by m1 plus dot 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 mn. So that's the formula, and this is obviously again vectors, so you need to keep a tab on the signs and the directions, else you will get a wrong answer. Okay, now I will give you a special formula which no book gives you, and most of the classes do not give this. That's why you guys are here. You always get some special things, some special gifts from me. I always give you some special tricks, tips, formulas which will make your life easy and also helps you avoid those traps, because a lot of you will fall on those traps otherwise. Now, momentum of the center of mass. Most likely you might not have seen this formula. So I'll give you that formula, no worries. So each particle has certain momentum. So guys, what is the momentum of the center of mass? It will be m1 plus m2 plus mn, because that's the total mass, into velocity of the center of mass. Now think about it. What is the velocity of the center of mass? Velocity of the center of mass is m1 v1 plus dot 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 many terms upon m1 plus dot 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 many terms. This over here is also m1 plus dot dot dot. Don't you see these two cancel? Don't you see these two cancel? So what will be remaining? m1 v1 plus dot dot dot. What is m1 v1 actually speaking? What is m1 v1? It's momentum. So it is just p1 plus p2 plus pn. That's it. So a lot of people think it is m1 p1 plus m2 p2 upon m1 plus m2. Wrong. It is just p1 plus p2 plus pn. That's it. I hope this is clear. Excelente, guys. Amazingo. Amazingo. Excelente. Excelento. Very good. Very good. Very good. Bahut badhiya. Okay. So let's solve this problem. Excellento patronum. Yes, Anu. Amazing. Kulu. Kulu doesn't go well. Okay. So let's do this problem, guys. Two particles, equal mass, have velocities 8i and 8j. First particle has acceleration, this I, this j. Second has no acceleration. What is the VCM and ACM, and what does the path look like? Let's solve this and see what do we get. Let's start with VCM first. So VCM will be m1. Okay, I'll just start with the formula directly because it's very simple. m1. Oh, the masses are equal. Very important word. So I'll just assume the mass to be m, and v1 is 8 I cap plus m2, same mass, 8 j cap divided by m plus m. So m goes, and you'll be getting 4 I cap plus 4 j cap. That is VCM. Isn't it obvious? Isn't it clear? Very simple. Now let's go to acceleration of the center of mass. Very similarly will be m1, masses are same, a1, okay, it's 5 I cap plus 5 j cap, m2 is m, but second guy's acceleration is 0 divided by m plus m. So this will make it 2.5 I cap plus 2.5 j cap. That's acceleration of center of mass. Now that was the first and the second part. The last part is, how does the path of the center of mass look like? A lot of people fail in this problem. Guys, draw it. It's very easy. Where is the velocity? 4i, 4j. That means this is the direction of the velocity. And what angle will it make? I'm pretty sure it makes 45 degrees because x and y components are same. Now think, where is the acceleration? Well, 2.5i, 2.5j. Oh, is this in the same direction? So that means acceleration of the center of mass is parallel to the velocity. What does it mean? If velocity and acceleration are in the same direction, what will happen, guys? It will move in a straight line. That's it. It will move in a straight line. That's it. And that is the final answer to this question. I hope it is clear. What an interesting question. Linear motion. If by chance, just imagine if by chance this came out to be negative, if by chance, then velocity will be here, acceleration will be like this. By chance, let's say. Then what will happen? The velocity will keep reducing, become 0, stop and turn and again come back. Just like free fall when you throw something up. It goes up, stops and comes down. So it will go there, stop and come back. So that will be also linear motion. If by chance velocity was here and acceleration was somewhere here, then it will do something like projectile motion. That's how it will do. Okay, very good, Ryan, Krito, Uncharted, Liti, Mandira. Very good, very good. Excellent. Let's go to the next question. Looks difficult, but it's not. Okay. Two blocks of masses 3 kg, 2 kg respectively are tied. Normal 8-wood machine, nothing different. The masses are held at rest. Find the acceleration. Okay. First, to find the acceleration, of the center of mass, I need to just use m1, which is 3, into a1 plus m2, which is 2, into a2 divided by m1 plus m2. Now what values will I substitute? That is something which we can see from this diagram. Guys, when I leave this system, okay, so the masses are given to be 3 kg and 2 kg, right? I think we have done how to solve this orally. Do you remember that opening up method? In case you are attending my sessions now only, or you are fresh to this channel, I would urge you to watch those sessions of Newton's laws, where I have taught a secret way of solving problems within few seconds, especially on those pulleys and Newton's laws. So there is a method called as opening up method, and from that method I can find what these accelerations are. So the acceleration of the blocks will be bigger mass minus smaller mass upon total mass into G, and that should give me 3 minus 2 1, 3 plus 2 5, so it will give me G by 5, which is nothing but 2 meters per second square. Alright, so that is 2 meters per second square. That's very easy. Yes, Prajwal, don't spam, but I remember you. Okay, how? If I know the acceleration, just put the values, that's it. So what will be A1? Believe me, A1 is not 2, it is minus 2. Remember I told you all these are vectors, keep in mind the sign. So acceleration of the first particle, heavier particle, is downwards. So please put minus 2 here, plus 2 into second guy's acceleration. Well, that is positive, it is going up. So put it as plus 2 divided by 5. So 3 2s are 6. So this will become minus 6. And this will become plus 4 divided by 5. So what will you get? You will get it as minus 2 by 5 meters per second square. What does this minus sign tell you? That the acceleration of the center of mass is downwards. That's what you get. That's how you solve problems. Very good, very good. I hope this is understood. That's how you solve problems. Now let me tell you a very special way of solving the same problem in a much special way using a special formula. Let's see, that's the last part of center of mass, and you will see that so many concepts of center of mass are getting cleared in today's session. So guys, do not forget to like the video. If you have not liked the video already, hit that like button, and if you are a new student, hit that subscribe button, because without those likes and without those subscriptions, guys, I won't get that energy. Very good. All right, so let's go ahead to the next concept, and that is Newton's modified law for center of mass. You know what is Newton's modified law? I'll tell you, don't worry. So guys, till now when we studied Newton's laws, you always had one mass or a block or a particle, and there were forces on it, F1, F2, etc. This F was the total force, and that body used to accelerate, right? Even when there were things like this, okay, you always took this particle separate, drew forces on this, and then you always wrote F is ma. But you never have chosen, in systems like this entire thing as a system. You have never chosen this as a system. Why? Because you did not have this formula, which I am going to give you. Because when you choose entire thing as a system, the problem that arises is, okay, I can draw all the forces, but then whose acceleration will I get? Will I get this guy's acceleration, or will I get this guy's acceleration? The answer is, I'll get neither of them. I'll get something else only. And that's what this law says. So if I have many particles, and this is my system, guys. So if this is my system, and if there are multiple forces acting on it, then if F1, F2, Fn are external, not internal, very, very important, are external forces, then F1 bar plus F2 bar plus Fn bar is going to be total mass into acceleration of the center of mass, like you would have guessed it. And this is Newton's modified formula please understand this M stands for M1 plus M2 plus Mn. That's it. So this is the modified formula. You should know this, very important. Alright. So how you can use this? Example, let me think. If net force on a system is 0, just think about it. Net force is 0. LHS will be 0. If LHS is 0, RHS should be 0. So if RHS is 0, who is 0? Mass is not 0. Acceleration is 0. So if net force is 0, center of mass won't have acceleration. What did I say? If net force is 0 external, then center of mass won't have acceleration. Now what does that mean? It means if center of mass is not accelerating, does not mean that individual particles are not accelerating. No. What I mean to say is, if one particle is accelerating this way, the other particle will be accelerating the other way, such that the center of mass will not accelerate. That's what I mean. So the particles' accelerations will adjust themselves so that the center of mass will not accelerate. That's what it is. Okay, great. Now let's see a problem on this. I'll show you some 1-2 numericals. Look at this guy throwing that bat. The bat's mass can be assumed to be concentrated here. Correct? The bat's mass can be assumed to be concentrated on the heavier end. Notice the bat's particles are moving in weird ways, but there is only one point on the bat which moves as if you condense the bat's mass into one particle and throw it here, it will move exactly similar to the point on the bat. I said if you condense the bat's mass into a single particle and throw it exactly from the same point, it will move the same way as the point on the bat. And this is what is important. The net external force on the bat, who is the net external force? Mg. Mg is the external force. So what will Mg do? It will not accelerate individual particles. What will it do? It will accelerate center of mass. And what happens when you accelerate with G? We all know it goes in a parabolic path. So the center of mass is the only point which goes in the parabolic path. Other particles go in different paths. I hope this is clear. So different points go in different paths. Only the center of mass goes in parabolic path by the Newton's modified law for center of mass, which says net force is mass into center of mass's acceleration, not any other particles. So same way we can talk about a rocket being launched. Observe this. Now what if this rocket explodes after being lifted off? What if it goes up in the air and explodes? Oh my god, look at that, the rocket just exploded. Now what is the acceleration of the center of mass is the question. Guys, it's very simple. When the rocket explodes, the force of explosion, is it external or is it internal? The force of explosion for the rocket, is it external or is it internal? Okay, science class is clear. Yes, internal. Yes, it is internal force, guys. So will the acceleration of center of mass depend on internal forces? No, right? I just told you. So the acceleration of center of mass only depends on external forces. External didn't change. So will the center of mass accelerate differently? No. So it will still continue to accelerate with G. Understand that. Even if the rocket explodes, one particle might fly here, another particle might fly here, but center of mass will continue. It's like, no, I am not going to change. I will still continue with the same path. You guys do whatever hell you want to. I will still continue the same way because on me the external force is still the same. That's what center of mass is going to say. Is it here? Very good. Excellent, guys. Excellent. Let's go to the next part of the problem. I mean, it's a same problem actually, but now I'm going to blow your minds like I always do. Alright, so let's blow your minds by solving this problem. Again the same problem. Yes, it's the same problem, but we'll do it differently. We'll do it differently. How we'll do it differently? Let's observe. This time, instead of taking individual particles, let's take both of them as a system. Yes, let's take both of them as a system. What are the external forces acting on them? Think about it. One is of course 3G, second is obviously 2G, and there are these two tensions acting from here. Correct? What do we have to find? Acceleration of center of mass. Okay, the center of mass, I don't know, it will be somewhere here and it will be having some acceleration, let's say ACM. I'll just leave it over there. Now, do I know the value of tension? Yes, if you remember the 8-wood machine problem, you would already know the value. It was, remember, 2 times M1 M2 divided by M1 plus M2 into G. That was the value that I got. Alright, so this is something which you should remember. It is very handy. M1 is 3, so 2 into 3 into 2 into 10 divided by 2 plus 3. 2 plus 3, 5. So this will become 2. 2 2s are 4. 4 2s are 8 and 8 3s are 24. So this will become 24 Newton. Just check this out. I hope I'm correct. Just see if I missed something. Yes, 24 Newton. Okay. Now let's use Newton's laws, guys. So what does it say? Net external force is equal to total mass into acceleration of center of mass. Let's use this and see what do we get. Net force 3g plus 2g. I'm taking downwards as positive because it is in the direction of acceleration. Minus t is equal to total mass, which is 3 plus 2 into ACM. Let's try this out. 3g plus 2g, 5g. 5g is nothing but 50 Newton minus 2 times of tension. Each tension is 24. 3 plus 2 is 5 into ACM. So 24 2s are 48. 50 minus 48, 2. So 2 is equal to 5 ACM. So what is ACM? It's 2 by 5 meters per second square. Guys, if you remember the value, wasn't it the same when we did it previously? Isn't it the same? It should be the same. I mean, if it wasn't the same, then I would probably close my shop and run away somewhere or hide my face. So it is the same. So I just wanted you to see both the methods are valid. It's up to you which method is convenient and which method is sometimes easy and sometimes difficult. Suryansh, why don't you comment after the session in the comment section? I will definitely help you out. Whatever your queries, put it in the comment section, not in the chat, so that I can read it properly. You can write a big thing also. I'll also give my Instagram handle after this. No problem, Suryansh. Yes. Now, yes, vector resolution alternate method. Let me tell you. See, very important trick, guys. Pay attention. So usually for these kind of problems, people face which is theta, which is 90 minus theta while drawing FBDs, right? So I gave you guys a method. What was the method I gave you? The method I gave you was, okay, if you have an inclined plane and you have a block like this, one thing you do is draw these lines along the plane, perpendicular to the plane, horizontal and vertical. And after this, just mark any angle as theta. So this will be also theta, this will be also theta, and this will be also theta. That's one way of doing it, correct? That's one way of doing it. Now let me tell you the second way of doing it. And what is the second way? Let me tell you, one sec. So again, you have a block over here like this, and this is angle theta, okay? This is your normal direction. What you do is take any two fingers, preferably the thumb and the pointing finger, hold it at 90 degrees. Come on, everybody try this out. Yes, try this out, guys. All right. Now, what you should do is place one finger horizontally and place the other finger vertical. Horizontal means like this, not like that. Like this, and the thumb will point downwards. So pointing finger one way and thumb downwards. The angle between them is how much? 90. Now if you rotate it like this, if the finger rotates by theta, how much will my thumb rotate by? Think about it. If my finger rotates by theta, my thumb will also rotate by theta, right? So guys, don't you see that this will be also theta? Because if my pointing finger rotates by theta, even this will be theta. So this can be used for solving problems. I hope this is clear, guys. So, in problems which involve some tensions like this, okay, ऐसा कुछ है, and maybe, I don't know, some angle over here is theta, I don't know, maybe some angle over here is phi. So you can use geometry also, like this is theta and this is phi, all right? Or you can also use these methods. So, you know, you can just hold this at 90 degrees, rotate it by phi. So you can see that this will be also phi. So, sorry, like this, phi. So you can rotate it and you can use this method as well. All right? Okay, great, great. So I hope you guys enjoyed today's session, and do not forget the offer ends today for joining our pro courses. So where you get all these benefits, I have listed it out here. You can see it again. You can also click on the link. So the coupon code is SHHPRO. So you'll get 50% off. Cap is 10,000 rupees. The offer ends tonight. Do not forget to join in today. And this is our Telegram group. I'll post all the answers there. And in case you have any more doubts, etc., and you want to ask me anything, feel free to ask me on my Instagram or in the comment section below. So in the comment section, you can ask something, or on my Instagram, which is Shreyas_Vedantu. And if you have enjoyed today's session, please like it, please share it. And if you're a new student, please subscribe it. Amazing, amazing. What an amazing session it was. Excellent, guys. Bye-bye. This was Shreyas here, your master teacher for physics, signing off. Take care, stay home, stay safe. Bye-bye.